Hi, this is Elizabeth Johnson, and I am going to present parts 4 through 6 of my lesson plan activity for advanced teaching and assessment methods. Let's begin with part 4, or activities. And we were given instructions to use the explicit teaching model for our activities to show a transfer of knowledge from the teacher to the student, or an I, we, you type model for our activities. So my activities for my lesson plan, where the objective was to be able to measure liquid precipitation, and here, let's look at our standards. The standard I was going to use is to represent data in tables, measure and estimate liquid volumes, and add, subtract, multiply one-step problems using volumes. The objective for this lesson was measure precipitation using a rain gauge, recorded it in units of liters, and begin design process to design and construct their own gauge. So the activities for my lesson presume previous lessons have introduced weather instruments, the vocabulary, maybe even some hands-on observations of these instruments, just so until we get to this point in our lesson, all I'll have to do as far as lecture goes is reinforce what a rain gauge is, its purpose as a weather instrument, to remind them that a rain gauge measures a liquid volume or precipitation. This can be done with a video clip or some pictures from our previous lessons to, again, reinforce the vocabulary and the purpose of a weather instrument. Moving from that lecture into guided practice, this is where technology can really come in play. And I am unsure of what my particular classroom will have in way of technology, but I know some of the classrooms at our elementary school do have the whiteboard and whiteboard software available in their rooms. Hopefully that will be available in my classroom, because that would make this particular guided practice activity far easier. But an alternative would be using good old-fashioned overhead projector. So through guided practice, I would project some type of static shape of a beaker, cylinder, something to represent a rain gauge on a large area for the entire class to be able to see. And as we would break into small groups, as previously explained in our other slide, my small groups will be based on our seating chart. And those small groups will be in groups of 4, and those small groups are based on student abilities. They'll change throughout the year based on behavior and other social skills, because it will be difficult to keep 2 chatty Cathy's together all year, or somebody who can't keep their hands to themselves. Some students just work better than others. And also having some higher performing students grouped with lower performing to help have some natural peer guidance and tutoring in place in those small groups. So those groups will be given their own graphic organizers, so their own little outlines of beakers or cylinders, something to represent a rain gauge, to practice these measuring volumes. This step would be done on paper. We could carry this from this lesson going forward. We can do some hands-on using actual cylinders, beakers, whatever they choose to represent their gauge. But for now, we're going to do it on paper and practice what does a measurement look like in the gauge. And from there, in small groups, practice, as that math standard asked us to do, practice simple one-step math problems. So that would be how many more, how many less, how much more, how much less. And within these small groups, also introduce that engineering design process. This was something that would be introduced earlier in the year, and something that would be as the focus of a STEM, or science, technology, engineering, and math class. As you can imagine, we would be working on lots. We'd have lots of real-world problems, or problems that we'd ask for them to apply an engineering design process to. And the purpose of this activity, as mentioned, transferring knowledge, would be to connect vocabulary and concepts to that design process in the future. So we would introduce the problem, which is we've got to design a rain gauge, something to collect liquid precipitation to be able to be measured. So that's where we're going to introduce in these small groups this problem for them to solve. And they'll begin to imagine or brainstorm ideas and designs for their own rain gauge, but maybe having some input from peers based on the design constraints that would be given or presented in the problem for them to solve, design problem. From those groups, from that group work, they would be released individually to work on their designs. And they'll have in the materials we'll see, they'll have a dedicated notebook for these projects. Independent practice, this is where I will be able to see that the skills have been transferred from myself to them. They will be working on their individual design processes. We'll be using technology and textbooks to kind of research further what is a rain gauge, what makes a good collection device, maybe some different visualizations of a rain gauge to help them brainstorm on that. Closure at the end of the lesson for this day, I will be looking at their notebook entries over time for a particular unit. So this is where they have recorded that in their notebook is something I will record at a future date, and that design project will be rated on a rubric of some sort. So I'll be looking for completeness and accuracy along the way, formatively, but eventually be assessed at the end of the unit. But for this particular day, an exit slip lets me check to see who got it and who didn't. Some individual practice problems using those beaker or cylinder outlines to measure, I put that in quotes, and liquids in quotes because it's not three-dimensional. It's not an actual measurement, but to see that they're getting that concept in this basic two-dimensional visualization, and to use that to solve simple math problems. Why? I've kind of gone over the why while I've talked about this, connecting the basic concepts and vocabulary of weather and climate and connecting it to a design challenge, which will be carried out through several lessons in the future from this one. So this is going to provide on-paper practice, give them a chance to kind of get the concept down to be able to carry that to a real-life application and connect it in the future with that. Also to practice those math skills that were given in this math standard. Working in small groups through their guided practice allows for some peer tutoring, as mentioned, and be able to kind of assess formatively as we go through those concepts to see who's getting it, who's not. And the exit slip will definitely allow me to assess individual mastery. So looking at materials and resources, notebook. Well, in my class, they will all have a dedicated notebook for making observations. This would include in this lesson their graphic organizers on making and taking measurements. That'll ultimately will serve as an assessment tool also. And particularly for their design projects during the whole course. Those notebooks will be graded for that. Of course, they need a pencil to be able to work for this. Textbooks, I put that down there for reinforcement of vocabulary or concepts presented as far as weather or weather instruments, and looking for design ideas for their design process research. Technology, I put iPads and computers for looking at those resources again on weather instruments, engineering design process, and I put an overhead projection system for that guided practice activity. Again, I'm hoping that maybe there could be some interactive whiteboard technology software that will allow students to be more interactive with the content, but an overhead projector system, just a good old-fashioned overhead would work for that too. And then graphic organizers. These would be those little beakers or cylinders that they could use a pencil to pencil in and show a measurement. So I can be able to assess, okay, you've got it. You would know how to look for this on a real rain gauge. And that would be their exit slip also. And then finally, evaluation. How am I going to know that they're understanding this lesson? And I put, these are very simple hows and whens, but I think it is that simple. And I put questioning, observation, formative assessment. Questions, particularly in lecture, it is so important to be engaging. Nobody wants to be like the professor off of Ferris Bueller. Bueller. So having questions, observing, looking for students that give me nonverbal cues that it's over their head or this is boring. We already know this. Looking for leaders who might be able to be better paired in my student groupings next time. Looking for those who could benefit from a peer tutor for the next lesson or even change within this one. Formative assessment, always assessing, checking for understanding. That exit slip at the end of the lesson lets me know individually who's got it and who doesn't, who still needs practice. And reviewing those notebook entries, circling the room, checking them out during their small group guided practice for the measurement skills. And then at the end of our weather unit where they have their problem is how I'll be able to tell that they understood the research process. So again, in a why, checking for understanding, helping students make connections to something they've learned in a previous lesson, and set them up to connect it to the future ones. Observing, looking for those nonverbal cues, seeing what students work within groups well and who struggles independently, and then checking for understanding of that design process, writing and mathematical skills, and individual mastery. I thank you very much.